Okay, kids, we're back. Chapter 3 review assignment number 15. Very interesting questions. Takes a lot of patience to do this question. Good organization of graphs. Nice free body diagrams. This question 15 and 16 actually as well. They are really at the heart of this entire chapter. So it says 6 dogs, each having a mass of 32 kilograms, pull a 325 kilogram sled horizontally across the snow, and we're given coefficients of static friction mu s and coefficient of kinetic friction mu k. How much force must each dog exert in order to move the sled at a constant velocity? That's A. So the first thing you need to do is you go G for given, and you need, as part of your given, okay, if you want to have good habits for solving problems in your next physics course, there's a reason I'm teaching you graphs and doing free body diagrams. So you draw a free body diagram, okay? And we're told that the mass of this sled is 325 kilograms. So we write that down as part of our given information. Next, we're told that we're going to move this sled at a constant velocity. Those last 2 words there are hugely important. Constant velocity, that's an incredible amount of information. Acceleration equals 0. That's huge. Okay, so then let's draw the forces. Force of the dogs. The dogs are going to pull the sled. Okay, then we're on the planet Earth. There is the force of gravity, which also goes by the name weight, right? And we know the equation for it right there. Since this is a horizontal surface and the object is not crashing through the snow, there must be a normal force that's supporting the sled. And that normal force, by definition of this horizontal surface, is equal in magnitude, but opposite in direction to the force of gravity. Now the sled is moving. So that means the type of friction involved here is the friction K, which is kinetic from the Greek for motion. That's the force of friction there. Now we're given an equation, but it's a restricted equation for the force of kinetic friction. Here it is. The magnitude of the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the magnitude of the normal force. Those are magnitude signs, and they have to be used. You can't write that equation without the magnitude signs. I know some of you haven't gotten to this point yet. Okay. Required. What is equal to the force 6 dogs or dogs? Let me just call it force dogs. Okay. Now listen to me carefully. These section 3.4 type questions, which we call them complex dynamics questions involving friction. Okay. Listen to this carefully. The way you start this type of problem is always the same. The way you start this type of problem is always the same. Analysis. F net equals MA, and F net, the other half of this, is the sum of all the forces, which would be force dog. Can I just put D for dog? You guys would get it, right? Force kinetic friction. force gravity near the surface of the earth and the normal force. These two equations always work together. In some questions, you start on this side and then you move over to the other side. Some questions, it's the opposite. You start here and move over to here. Depends on the question. But that's the way you start all of these questions. The one thing you really need to remember is, to begin with, look, normal force and the force of gravity are of equal magnitude, but opposite directions, so they cancel out. Why do they cancel? It's on a horizontal surface. So we have F net equals force dog plus force kinetic friction. Okay? Now, to make life easier, you need to really use the fact that, hold on, Miss WP came to visit. I'm going to pause the recording. So, as I was saying, you got to remember that this object is moving with a constant velocity. So if you think about that, your acceleration is 0, which means your net force is equal to 0. So that means this is equal to 0. Which means the thing you're trying to calculate, force of the dogs is just negative of the force of friction. So then we're reduced to, well, if I want to calculate the force that comes from the dog, what I'm being asked then to do is calculate the force of friction, kinetic friction. Is there an equation for this? Yes, there is. There is an equation for this. I wrote it right here. Oh, I don't know why it does that. I wrote it right there. So there is an equation for this. But listen to me now so you don't forget about it later. I am the Terminator. Okay? Kids, this is the heart of it right here. These types of problems. Let's say you're doing an assignment on this stuff, and you're like, I don't know what the hell's going on. I don't know what to do. What do I do? Just by default, write down F net equals MA. Write down F net is the sum of all forces and see where it takes you. Honest to goodness, 9 times out of 10, you'll answer the question. Okay? Did this help you?